Coda, Our Genes and Our Future. The event on which this fiction is founded has been supposed by Dr. Darwin and some of the physiological writers of Germany as not of impossible occurrence. So begins Percy Bysshe Shelley's anonymous preface to his wife, Mary Shelley's novel Frankenstein, a story whose grip on the modern imagination has exceeded by far that of anything the poet himself ever wrote. Perhaps no work since Frankenstein has so hauntingly captured the terrifying thrill of science at the point of discovering the secret of life. And probably none has dealt so profoundly with the social consequences of having appropriated such godlike power. The idea of animating the inanimate and improving upon life as it occurs naturally on Earth had captured the human imagination long before the publication of Mary Shelley's work in 1818. Greek mythology tells of the sculptor Pygmalion, who successfully petitioned Aphrodite, goddess of love, to breathe life into the statue of the beautiful woman he had carved from ivory. But it was during the feverish burst of scientific progress following the Enlightenment that it first dawned upon scientists that the secret of life might be within human reach. Indeed, the Dr. Darwin to whom the preface refers is not the familiar Charles, but rather his grandfather, Erasmus, whose experimental use of electricity to spark life back into dead body parts fascinated his acquaintance, Shelley. In retrospect, we know that Dr. Darwin's exploration of what was called galvanism was a red herring. The secret of life remained a secret until 1953. Only with the discovery of the double helix and the ensuing genetic revolution have we had grounds for thinking that the powers held traditionally to be the exclusive property of the gods might one day be ours. Life, we now know, is nothing but a vast array of coordinated chemical reactions. The secret to that coordination is the breathtakingly complex set of instructions inscribed, again chemically, in our DNA. But we still have a long way to go on our journey toward a full understanding of how DNA does its work. In the study of human consciousness, for example, our knowledge is so rudimentary that arguments incorporating some element of vitalism persist, even as these notions have been debunked elsewhere. Nevertheless, both our understanding of life and our demonstrated ability to manipulate it are facts of our culture. Not surprisingly, then, Mary Shelley has many would-be successors. Artists and scientists alike have been keen to explore the ramifications of our newfound genetic knowledge. Many of these efforts are shallow and betray their creators' ignorance of what is and is not biologically feasible. But one in particular stands out in my mind as raising important questions, and doing so in a stylish and compelling way. Andrew Niccol's 1997 film, Gattaca, carries to the present limits of our imagination the implications of a society obsessed with genetic perfection. In a future world, two types of humans exist: a genetically enhanced ruling class and an underclass that lives with the imperfect genetic endowments of today's humans. Supersensitive DNA analyses ensure that the plum jobs go to the genetic elite, while invalids are discriminated against at every turn. Gattaca's hero is the invalid Vincent, Ethan Hawke, conceived in the heat of reckless passion by a couple in the back of a car. Vincent's younger brother, Anton, is later properly engineered in the laboratory, and so endowed with all the finest genetic attributes. As the two grow up, Vincent is reminded of his own inferiority every time he tries, fruitlessly, to best his little brother in swim races. Genetic discrimination eventually forces Vincent to accept a menial job as a porter with the Gattaca Corporation. At Gattaca, Vincent nurtures an impossible dream: to travel into space. But to qualify for the manned mission to Titan, he must conceal his invalid status. He therefore assumes the identity of the genetically elite Jerome, Jude Law, a one-time athlete who, crippled in an accident, needs Vincent's help. Vincent buys samples of Jerome's hair and urine and uses them to secure illicit admission into the flight training program. All seems to be going well when he encounters the statuesque Irene, Uma Thurman, and falls in love. But a week before he's to fly off into space, disaster strikes. The mission director is murdered, and in the ensuing police investigation, the hair of an invalid is discovered at the crime scene. An eyelash Vincent has lost threatens not only to dash his desperate dream, but to unjustly implicate him by DNA evidence as the director's murderer. Vincent's unmaking seems foreordained, but he evades a nightmarish genetic dragnet until another of Gattaca's directors is found to be the actual murderer. The film's ending is only semi-happy. Vincent will fly off into space, but without Irene, who is found to carry certain genetic imperfections incompatible with long space missions. In real life, the two actors who play Vincent and Irene have their futures more under their personal control. Ethan Hawke and Uma Thurman later married and now live in New York City. Few, if any of us, would wish to imagine our descendants living under the sort of genetic tyranny suggested by Gattaca. Setting aside the question of whether the scenario foreseen is technologically feasible, we must address the central issue raised by the film. Does DNA knowledge make a genetic caste system inevitable? A world of congenital haves and have-nots? The most pessimistic commentators foresee an even worse scenario. Might we one day go so far as to breed a race of clones, condemned to servile lives, mandated by their DNA? Rather than strive to fortify the weak, would we aim to make the descendants of the strong ever stronger? Most fundamentally, should we manipulate human genes at all? The answers to these questions depend very much on our views of